All right. Good morning, gentlemen. Today we're going to talk about tension and compression forces. And we started this concept on Wednesday where I gave you a document that was about a page and a half to read. And it talked about the different basic bridge types. And then it talked about tension and compression forces. So you were introduced to this concept and you had to do a quick activity and kind of try to determine what the tension and compression forces were. So I did post the answers to that. I'm going to go through the notes now that we would have gone through in class, and then you can also go back through that activity and make any changes based on your new knowledge on tension and compression. So, tensile strength, okay, is the maximum internal force that a member can carry before it fails. So, a member, when we're talking about a member, we're talking about the parts of a bridge, the beams of a bridge, or the beams in a building, okay? So the maximum internal force or the tension force that a member can carry before it fails. So tension force is one that pulls materials apart. And the best way to see that illustrated, one is in this drawing that you have right in front of you that shows a rectangular object and it being pulled both ways. So it's being stretched and it's being tensioned. Another way to think about it is rope, okay? So this is really doing nothing. But here, when you're pulling it apart, okay, it's under tension. And this is actually tension forces, and you'll learn more about tension forces in physics. But anytime we talk about tension forces in physics, we're talking about some type of rope or cable or string or something like that. So think of a rope being pulled. That is what illustrates tension. Okay? Compressive strength. Okay, compressive strength is the maximum compression force that a member can carry before it fails. So where tension was something being stretched, compressive forces are ones that squeeze the material together. So here you have kind of a square rectangular object that's being pushed together and being compressed. Okay, if we were in the classroom, I would give you all marshmallows so that you could squeeze the marshmallows and see how they compress, and then they end up bouncing back to what their typical shape is. I couldn't find any marshmallows in my pantry because the kids had gotten into them, but I did find this Pirates squishy ball. So I can compress it, push it down, squeeze it together, and then release it, and it goes back to its normal shape. Okay, squeezing it, going back to its normal shape. So that is compressive force and compression. Here, and this kind of goes along with the activity that you guys did, okay? But if we put a weight on a beam like that, and that beam is an I-beam, they show you over to the side that it's an I-beam, okay? If you put a weight on that, the red line that is directly under the weight is being compressed, okay? But the red line at the base is being stretched. So the bottom part of the I-beam is being stretched or tension. The top of that I-beam is being compressed. And so your I-beam is actually two different things are happening to it. Also, your green stanchions on the side, those would also be being compressed. And here are two other illustrations. One is going to be your arch bridge and the other is the suspension bridge. So the red is showing the compressive forces. If there's a weight pushing down on the bridge, on the suspension bridge, let's talk about the suspension bridge to the left or to your right. If the weight is being applied, okay, then all those cables are being stretched. So those are all tension forces in all the cables. But the middle beams in the middle that the ropes are attached to, those are being compressed. Okay. And likewise, in your arch bridge, you pretty much only have compressive forces because they're being, when a weight is applied, it's, compressing the structure. So your compressive forces are indicated by your red arrows, and then your tension forces are indicated by your blue arrows. So hopefully that helps explain what you guys did on Wednesday, and your activity for today is listed in Moodle. Have fun. And after the weekend, we're going to talk about equilibrium on Tuesday, and then you guys will take a break for Easter break, and then we'll start evaluating truss after Easter break. Thanks, guys. Have a great weekend.